So if you, my friends, decided to wire the garage, if it's detached, or you have to wire it because it's attached, you need one light. The suggestion, Chris, if you read through it, the number of the light has to be one more the number of the cars. So if your car is 2-car garage, 3 lights, 1-car garage, 2 lights, 4-car garage, 5 lights. These are suggestions. Your lights is suggested to be set in the back, and everybody knows why, because the door opens, the garage door opens, so it covers this area. You might not have light. What I do with my garage too, guys, is I would put also light in this area. They're running, my lights are running all over. So I would put lights in this area and feed them. It's really nice, especially in Minnesota in the winter, when you're working on a heated garage, guys, to close the garage and be able to work in this area. This will be dark. So just for our situation here in the Midwest, in the cold climate, it's really nice to have 3 lights here too, where you can work. You close the garage and you work in it. We have 1 circuit dedicated. Do we have to have a dedicated circuit, guys, for garage? No, you don't have to. I think the dedicated circuit is 15. They're feeding GFCI right here, and they are feeding the outdoor. Can you see this light here, Chris? This light here must have, because you have a service door. You have a service door, you have to have a light. You can have a switch for it, or you can have a photo cell on it, no problem. So these are the 3 lights also must have. They're switching the 3 lights, guys, from 3 different locations using 2 3-way switches and 1 4-way switch. Everybody can see that? From 3 different locations. Do you have to do that? No. Here's the 3 different locations that they're switching the lights from. And that's why you have, Tao, my friend, why do you think we have 4 conductors here? Anybody can tell me, why do we have 4 conductors here? It's between 3 and 4-way switch. You have to have 2 travelers, right? And you need to have a neutral, because it's by code 2011 you have to have neutral. What do you think the last one? Switched hot. In this case, it's going to be switched hot. So 2 travelers, a neutral, and a switched hot. Any question as how they did them? So this is to control these lights. I have a garage door opener here, has to be GFCI by code. In 2011, Nick, this garage door receptacle plugged in, most of them are plugged in, they cannot be GFCI. It has, the GFCI cannot, the receptacle cannot be GFCI here. It has to be fed through, because it's readily accessible. So keep this in mind. You have to, the only way I can make this outlet here readily accessible if I put the GFCI on the wall. So what would I do? I take the light, the GFCI from here, and feed through directly to this receptacle. Okay, so that's basically what they're doing here. They put more receptacle than needed. It's a good idea. If you ask me, in my opinion, if you have a 2-car garage, personally, if you ask me a 2-car garage, I really would like to see at least 2 outlets in every wall. So I like these 2 outlets here. Will be really nice to have another 1 outlet here and 1 in this area, and 2 outlets in this wall. So really nice to have 2 outlets in this wall. As we know, if you're a handyman or woman, it comes very handy as you work. If you want to do it to code, 1 GFCI receptacle, 1 for the garage door opener, and 1 light with 1 switch, and call it a day, unless the owner wants you to do something different. Any question, guys, about this? Any question? So 1 circuit. We talked about car garage door openers, guys. There's a couple of requirements. They talk about where to position your light. Position them to the back. We know why. And closer to the hood if you're working. It's really hard to position them in a situation where you work under the hood of the car and be able to see. You have to have a task light. But that's a couple of suggestions. Away from the cars. So your cars will be right in here. Can you guys see right in between? Try to situate them. Film my friend in a place where they can be located. Right, not right at the top of the car. So if you can, place them where between the cars if possible. And these are all suggestions that they have for us. Position light forward illuminate. Okay, and the hood. Okay, this. Okay, here's the requirement for the garage. That's the only requirement for your garage. You have to have 1 GFCI receptacle. These are the articles that talks about it. 1 GFCI receptacle at least. Does it have to be 20 amps? No. Does it have to be 15 amps? Could be 20 or 15 amps. So 1 GFCI receptacle. Do I need a separate circuit, guys, to feed the garage? Do I need a separate circuit to feed the garage? Good idea. But do I need to? No. Can I steal it from anywhere else other than kitchen, laundry, or bathroom circuits? Yes. Does the garage, all the receptacles in the garage, do they have to be arc fault circuit interrupters? No. The light and the receptacle in the garage. Dustin, my friend, do they have to be arc fault circuit interrupters? No. They don't have to be arc fault circuit interrupters. Okay. So that's basically it for the garage. One more time. One GFCI receptacle. One light, switched light. If you have a service door, you have to have a light outdoor for the service door. The door, the garage door light, you don't have to have this by code, but it's a good idea to have them. As you guys can see how they put right here. Can you guys see where they put the lights right in here? These actually switched from a different circuit here. Then they put a light right in the middle of the yard, guys. Yard light or that's okay. It's not code. It's a good idea. So landscape lighting. So they put a light in their yard, in their front yard. Any question about the garage, guys, before we move into another topic called landscaping light?
If one looks at the wiring scheme here, and you figure a garage is probably 22 to 24 feet.
Okay.
And then you take a look at the current path based on the way it's wired. Is there going to be a voltage drop problem based on yesterday's exercise?
Very good point. If you pull 15 amp out of the 15 amp circuit, yes. Most of the time, you usually are not, but it could be. If you're pulling 15 amp out of the 15 amp circuit, it could be. But most of the time, guys, rarely if you're pulling 7 amps out of them. For example, the garage door opener takes 5 amps based on the calculation. How long will it take you to open the garage? You push the button within 5 seconds, the garage, maybe 7 seconds, the garage is open. Now these 5 amps, what happened to them? They're out the window, right? Then the leftover is what? Receptacle, lights. How many lights you're going to be putting in there, depending on what type of lights. If you're putting, say, 3 lights in this case, each of them is 100. Take a 300 divide by 120, that will give you 2 amps, 2.2 amps. And remember, you're looking for 15 amps yet. 2.2 amps. So all the lights are on 2.3 amps, say. And then if you have a receptacle plugged in machine you're working on, unless it's a welder or whatever, you're going to have another 2-3 amps on that machine. Unless you make a shop there, which is a whole different story, you're going to be using one machine at a time. I don't know about you, but you're not going to be using, even if you have 6 machines, you're not going to be using 6 machines at the same time. So each machine will have 3 amps, plus 3 amps for like 6 amps. Add the extra amp for whatever, 7 amps. So you do your voltage drop based on 7 amps, and you're good. So if you have a detached garage, if you wire with 15 with number 14, it's good. Excellent is number 12. I always like to wire garage, especially the receptacle, with number 12.
In theory, the power could be running about 100 feet here. I'm just thinking in terms of the voltage presented to the garage motor or the voltage.
You're good. You're good. Yeah, you're good. Based on the full load amp, not the 15 amp calculation. Because the 15 gave us what, 36? Was it 36, I think, or 25? No, 36 feet. That's if you're pulling the 15 amps at the end of the 36 run. But look at them. The challenge in real life, guys, Phil, my friend, the lights are not concentrated in one location. They're all over. So the voltage drop, it would be less, because if you look at all these lights, they're not at the end of the run. They're all over in between, which means it lessens the problem of low voltage drop. Not an issue. Low voltage lighting requirements. Most of the time, guys, you have a low voltage, you plant these lights. You've seen a couple of pictures for them. They're 120. They come from an isolated transformer, and it feeds all these lights 24 volt. I had my neighbor one time, I always say this story. He was doing his lights and he was tying the wires on the lights. When he was tying these wires, he's tying the hot and the neutral together. So keep blowing and burning that circuit, the transformer, isolated transformer. Twice he went to Home Depot to buy it, and he burned it, keep burning him, until finally he came to me and said, "There's something wrong." And he was, instead of bringing the hot and the neutral at 2 different locations on the light, he was tying the hot and neutral together Now this is 24 volt and tying them to one end. So he's shorting them, but the problem is because they are 24 volt, they wouldn't trip the circuit breaker. Remember, they're 24 volt, you're shorting them. 24 volt, they wouldn't trip the circuit breaker fast enough to protect the transformer. So it keeps heating up, heating up, heating up until the transformer burns. But that's kind of his issue. Okay, here's what we're talking about, guys. You're going to have a 120 volt to a 12 volt transformer. You plug it into a GFCI protected in-use cover, right? The weatherproof receptacle, and then you feed all your stuff. Now, if the problem with my friend here is he was tying the hot and the neutral, shorting at this point. If you short at this point here, at 24 shorting him, guys, the circuit breaker that protects this whole equipment is not going to wake up fast enough before the smoke starts coming out of this baby. Before smoke starts coming out of this baby. Any question, guys, about this, the landscaping light? Do I have to have landscaping light? No. Is it a good idea? Yeah, I guess decorative. In this day and age, they have all these solar ones. You guys have seen them where you can independently stand alone. You can plant them anywhere. They receive and charge. They receive the light during the day, charge it, and then I think they have some type of a capacitor or something. They release a small amount of energy at night to keep these lights on. Any question, guys, about this? So, Rob, my friend, if you are to do a system like this, here's what you need to understand. Number one, you have to have a wet location enclosure, in-use cover, GFCI receptacle, weatherproof GFCI receptacle, weatherproof, tamper-proof, because it's also in a residential, tamper-proof, and that's it. And then the whole system here, you buy it, guys, and you assemble these. You assemble them hot to hot, neutral to neutral, and you plant them wherever they are, and they don't have to be directly buried. They're 24 volt. I think there's a requirement for 6 inches, I believe, or so for them. Any question, guys, about this? Light. So outdoor wiring, GFCI. You can use UF cable or you can use THHW conductors with conduit. Most likely in a house, guys, we use UF cable. UF cable is well respected, rated for two things: to be directly buried, no conduits. But when you emerge from the ground, you have to protect it though. Remember, when a cable emerges from the ground, you have to protect 18 feet below the ground up to 8 foot if it has to go that high. So you have to protect it when it emerges from the ground. This one is really good, guys. Sheet. It will tell you if you have how big of a box, tau, my friend, you can support from conduit. You can see them if you walk downtown Minneapolis and Hennepin. You see these conduit PVC coming from the bottom and supporting boxes. How big of a box you can support from a conduit, not from a wall. You're not supporting from a wall or a structure, from a conduit. If you read through it, it has to be 100 cubic inches or less. The ones that you can support, and not larger. So it has to be, these boxes cannot be larger than 100 cubic inches. So you're not going to fit a big box and support it from a conduit, number one. And you need 2 conduits over here, threaded or with a hub when you support them. And if it doesn't have equipment, probably you can rigid nail conduit or IMC or PVC can get you the support. But what they don't want you to do is to support the box from one conduit like this, because it could twist and so forth. So this is what's saying, if you are to design a system where you want to support the box directly from a conduit, you're looking at rigid or intermediate conduits. So to avoid doing this, Chris, what do? You put this box against the wall, the outdoor wall, or you build the structure to support it if you don't want to use rigid or intermediate. PVC also, PVC Schedule 80 will get you there. Good support. PVC Schedule 80 will get you to support these 2 conduits coming from the bottom. Any question, guys, about supporting these? Rigid, PVC, intermediate, 2 conduits from the bottom. Or it could be 1 conduit from the bottom, 1 from the side is okay too, to support these boxes. Direct buried cables, guys, UF. We'll talk about the depth and so forth. Can I, is this code? Can I mount a fixture to a tree, to a vegetation? Yes. Mounting a fixture to a vegetation, yes. Using the vegetation as your poles to support the power lines, no. Does that make sense? So this is where this installation conformed to the code, does not permit bands of conductor, but it does not prohibit installation decorative lights as shown. So if you have a decorative light, you attach it to a tree, that's okay. Um, Obviously, if this is UF cable, what do you need to do with the UF cable as it emerges out of the ground? Protection with PVC schedule. You have to have protection. Protection will give you schedule 80 all the way up to 8 feet or the fixture. Protection from physical damage. Now, any question is putting a decorative light on a tree, no problem. Now, taking a cable from tree to tree to tree to third tree, no. You have to have a poles. Okay, underground wiring. There's a table that we'll talk about the underground wiring. Here's what you cannot do. If I have a shed on my farm, can I use the trees to take the power lines to the shed? Will be nice. I've seen people doing it, but not according to the code. Tree to tree to tree, you can't. Feeders or branch circuits. Feeders, branch circuits, or service conductor. Remember the 3 circuits? You cannot. No, no, no. Okay, that will leave us, bring us to this table. Table 300.5 give you the depth of the minimum depth that you have to to put your conduit at. Take this one. If you're using rigid or intermediate conduit, if you're using a rigid or intermediate conduit, how much do you need? Right directly, you put your rigid, bury it. No concrete, nothing. You can bury it directly 6 inches, and you put dirt, 6 inches of dirt in rigid intermediate. If you are using direct buried cable, number 12 here, this is the special condition that we talked about, guys. That's only for 120 up to 20 amp GFCI protected circuit in a residential. If you do that, look at the limitation. 120, 20 amp GFCI protected circuit, you can bury them up to a foot. Where would you put the GFCI? Right at the head GFCI, not receptacle this time. GFCI circuit breaker to protect the whole cable. They allow you residential only to go 12 feet, so people are lazy, they don't want to dig too deep. 99% of the time, Nick, my friend, you're going to be either here or here. If you use a PVC conduit, which is the most common conduit we put, like I told you guys, we use PVC. You pull conductors inside them, you can go 18 inches, no concrete, nothing, 18 inches. No concrete, nothing, 18 inches. If you bury the direct cable, UF cable, in other than GFCI protected and so forth, non-residential, you have to bury direct buried cable at 24 inches. Any question, guys, about these requirements? Very, very important. This table is extremely, extremely important. Any question about that? So where are you going to be? In residential, guys, like our project that we're doing, your choice. If you want to put a GFCI, since we're using PVC, I asked most of you guys to use PVC. We're sitting at what? 18 inches. How deep is my trench? 18 inches. Why? Because we're using PVC for the most part, and we're pulling conductors inside the PVC, not a direct cable, buried cable. Okay, overhead garage. Any question? I'll come back to this table in a second too. Garage door opener, guys. Garage door opener takes, for on average, 5 amps. Do I need a dedicated circuit for the garage door opener? No. Most of the time, that's why I said it's always really nice to bring at least a 15 amp circuit, feed everything in the garage, unless you want to make it a shop. A lot of people, guys, bring a 60 amp sub panel, feed their garage, and feed multiple compressors and so forth. If you're a handyman or woman, the best way is to take a 60 amp panel and pull a feeder 60 amp in one corner and put your compressors if you're working and all this good stuff, 240 equipments and your air conditioning in the window and all this stuff directly from a 60 amp panel. For the rest of us who are not as handy, all what you need, the best design for it will be a 15 amp circuit feeding all the receptacles, including the garage door opener. Any question, guys, about that? They're saying is it's a good idea. Some inspector, some location, never heard of it here. They require people to have a garage door opener. Okay, here you go. On a separate circuit. Okay, this is just the same circuit, guys, that we did. Any comments? Any question about this circuit? Comments? Question about this circuit? Now, next, my friend, you're going to take this circuit and do a point-to-point wiring for it. Just to remind you, when we do a point-to-point wiring, every outlet or every light need at least two conductors, a hot and a neutral, right? A switched hot and a neutral if it's light, a hot and a neutral if it's an outlet. If you have a three-way switches, you need two travelers and a neutral and either a hot or a direct hot. So you need 4 conductors. You're looking at 4 conductors. So keep this in mind as you go through wiring these. Here's the options, Rob, my friend, you have for your garage. These are not code suggestions. Since you guys are designers, go more than a code. Somebody's to come with a 6-car garage. How many lights you suggest for them? 6 plus 1 is 7 lights. But what I add to this, what personally I add to this one, is I would add another 2 here. If you're a handyman or woman, I would add the double one right in here. Why? Because in the winter you can shut this door and work. And I did it for my garage. I went wired my garage, added more lights in the front, because in the winter, take my cars out, work inside, some woodwork or whatever you need to work in, heat the garage. It comes really handy. If it's your garage and it's up to code, you're lucky if I can put your 2 lights here and move on. Any question, guys, about this? What does the code say? The code, you can get away with one light based on the code. How do you turn the light on and off? You can turn the light on and off from a keyless socket like this, so you can have a switch. Most of the time, guys, we have 99% of the time we're going to have a wall-mounted switch for the garage. Wall-mounted switch. We talked about these guys, the 24 volt. Warning, Oladipo, because I know you're going to be wearing them. When you go over here, please don't tie the hot and the neutral together and tie it to the equipment. Especially on the 24 volt. On the 24 volt, because if you do that, like my neighbor did, you're going to get this one smoke out of this, and the circuit breaker here wouldn't wake up yet. Would not wake up. We talked about this one too. Front lights. This is the front porch light or the front yard light. A couple of lights that you can use, guys. Decorative lights. Plug in. We talked about this one where you have to have 2 conduits, rigid, intermediate, PVC. EMT is not the best choice with that. For receptacles, guys, you need to have in-use cover. This is not, doesn't look like an in-use cover unless it's inside. Yeah, it's pushed in. It is an in-use cover. Can you guys see what an in-use cover is? You push each one of them, and then you can cover it because it's wet location. That bubble. This one is not a bubble because the receptacle is set back. That's actually nicer than a bubble. Don't you think so? Yes, sir. Oh, that has been since 2005. Or even, gosh, I want to say 2000, at least 2005, not 2002 maybe even. Long time ago. Definitely in 2008 has been there. I think it's 2002 even. 2002. That's not new one. But this receptacle, what's new, Rob, this receptacle have to be GFCI, weatherproof, tamper resistant, in-use cover. All these, this receptacle have to be. Arc fault? No, not really, outside. Yes, sir. Yes. Yes. Grandfather did? Yes. Except, take this. Did you say your grandfather? Okay, so but say your parents' house does not have, take this. If you were to go change this one right now, if you go to change this one, this receptacle based on 2011, change it, not pulling wire. You have to have weatherproof, GFCI, tamper resistant receptacle. In use cover, a lot of inspector will force you to use it also in use cover. If you change it, if you don't change it, we're okay. We trust that you're not going to mess with it. Okay, this is just how to put this recessed cover. NM cable, number 12, grounding. We talked about the trees, don't use that one. Couple of different things. And for sight light, guys, they don't want you. Do you have to pull an equipment grounding conductor to the sight light or to the front yard light? Yes. Based on the code, guys, you have to pull a hot and a neutral and a ground with every circuit. So the circuit that's coming from right in here, you can see that circuit here. I'm bringing my hot all the way to this lighting fixture. And then from the other side, I brought my neutral, as you guys can see, all the way, direct buried cable, all the way to here. Now, some people can say, well, this pole is in the ground. It's grounded through the pole. No. So the code, what the code requires you to do is requires you to take a second conductor here. That's a grounding conductor directly and tie it to the fixture.
Does the UF not carry a ground system?
Yes, it does carry a ground. It does, typically now. But so long story short, they don't want you to run two wires. Why? They don't want you to depend on the ground. The ground shall not be a means of return for the ground fault. The ground shall not be, it's high impedance. If you have a short circuit, guys, line to ground, if you have a line to ground here, and Chad is holding on a hot conductor because that pole is defective, the current will go cook you first before it wake up the circuit breaker. Why? Because of the high impedance in the ground. Why do you think we send the second wire? If you send the second wire, suppose accidentally that hot touches the ground for whatever reason. This is a piece of copper going direct from the source into the sink or into the load. That copper, guys, make the current so fast, high enough that the circuit breaker will open immediately. Who cares? You're not going to be electrocuted. What do you need to know? You need to know every time you send a circuit anywhere, you always send three conductors, at least hot, neutral, and ground. You do not want to depend on the ground to be your equipment grounding conductor because the impedance is too high. Okay, we got that one. Please look at the depth, very important, guys. And as I said, you are going to be in 99%, 18, and 24. So you go to Shad Cool Erickson. As engineers, guys, we specify when we have conduits, direct buried conduits, most of the time, 24 inches to the top and move on. 24 inches to the top and move on. If you have PVC, though, you can go as low as 18. This is only direct buried cable, 24. But as I said, when we specify even conduits, we specify them 24, more than what the code even has. Residential only for 120 volt, 20 amp, GFCI protected in residential. Look at the restriction on that one. If that's your situation, you can go 12 inches, direct buried cable, UF direct buried cable. That's how they can get away from between a garage and a house, pull an under cable with 1 foot. Yes? Yes. You go maximum, you start derating because you're trapping heat. This goes into a whole, it takes you in a whole different animal. When we have,
Then what type of grade you're putting it in? Like, what if you're burying it in clay versus sand soil? Or
this is not direct buried. You can bury it with whatever you want to bury at this point. As long as you don't encase in concrete. You're not encasing in concrete, are you? No encasing in concrete.
No.
I'm sorry.
Yeah.
Yeah, you talk about direct buried. Now, of course, if you're direct bury a cable, you're not going to go put big rocks right to the top of a cable. You have to put some sand around the table. What we do, guys, if it's your rocky, if that's what you're talking about, direct buried cable, you put your cable and then you put some sand or soil, not sharp objects right around the table. Then you can put your rocks. They don't want you to put sharp rocks right to the top of a cable because it cuts through the cable as you bury them. Is that what you were after?
Yeah,
Yeah.
yeah, I was just talking about that.
Yeah. And the same thing with the conduit. What we do, guys, for conduit, if you have sharp rocks, what they do is you bury your conduit, then you put an inch around it, sand or something soft, and then you put your rocks and all this good stuff. You don't want to damage the conduit or the cable as you bury it. Okay. This one is really interesting. If it's a rocky place, guys, they allow you to put conduits and you bury them with 2 inches of concrete. We'll talk about this table, guys, more as we go to the commercial too. Look at this, surface or driveway or parking areas. If your situation is under a surface or a parking or making it impossible to attain, if you're under, look at that, direct buried cable, they lower it a little bit to 18. Can you guys see that? Non-metallic, they lower, it was 18 anyway. So they lowered it a little bit, 18 for rigid metal conduits if you have a concrete right at the top of it. For residential, continue to be 12 inches. Continue to be 12 inches. If it's under a park area or driveways or parkways and so forth. Any comments, guys, about this? Any comments about the depth? Really, the only depth that you need to understand right now is the 12-inch for GFCI protected, 18 inches for PVC for our project. And if you decided to use a UF cable, it's going to be 24 inches. Okay, conduit, protecting. Talk about the ground. Garage door opener. This is just a low voltage picture, guys, of how the garage door opener works. And this is, I don't know, they use 1822 or something like that cable, something similar to that 1822 wire. Can you guys see that these are push buttons where you can open your garage from multiple locations? For your garage door opener, overhead operator, so you can push all of them on parallel. When you push it, you energize the coil over here, and the coil close the magnetic starter and allow the garage to open and close. So remote push button. Sometimes they have, I think, one that goes that way and one goes the other way, reverse and forward. Yes, sir.
Yeah, please, I want to look at the wiring diagram once again.
Let's go back one more time. Okay, here.
The wiring diagram of the garage.
The wiring, what's coming in a second. Yeah, they mean the wiring diagram of the garage. Let's go this here. Okay. Single blat. If you have a square for the garage, you don't have. For you guys know in low voltage, do I need a box for low voltage? Do I need a box for low voltage? Unlike high voltage, you need. Can I terminate a 120 up in the air here? Just have a splice like some people do. No. If you terminate high voltage, you need a box. If you terminate low voltage, you don't need a box. Take this coaxial cable. If I have a coaxial cable, you see them without a box like this. It's a good idea to have a box, but you don't need a box for low voltage cable. 24 volt, 12 volt. Do they put them in a box when they terminate these sensors? They don't. You don't have to put them in a box. So keep aware of that. Some garage door openers, guys, they have an current, a separate dual element time delay fuse to protect the garage. Is a good idea. The reason for this, because if you have this is the garage door, this circuit breaker 15 amps is not rated directly to protect your motor. So what some manufacturers do is recommend, I don't know if you've seen them, they have a fuse right where they feed, it's a fused receptacle. So they have the fuse right and the receptacle right next to it, or a switched fuse outlet where you need the switch because it's a motor, disconnect it, and you need a fuse to protect it from overload and overcurrent. They call this one, this is called supplemental overcurrent protection device. Is it required? No. Is it good? Yes.
Don't most of the motors have a reach? Because everyone has to.
They do have an overload in them.
Overload.
They have an overload. This is really supplemental overcurrent protection device, mainly short circuit. And will give you dual, if it's dual element, will give you overload too. Calculating the circuit. Here's the depth, guys, the table that all this came from, condition 1. We go over this table, Rob, in details when we go to the commercial. And this is your wiring diagram that you guys are going to do for your friend Chad. And before I leave, my friend wants to look at, let's go directly, here you go. What do you have?
Yeah, I don't know the entrance there.
Right here?
No, that one. Yeah, the three-way switches, there are two. I don't
Yeah,
know what the
one's
second
not
one
used
is.
in this circuit, in
Yeah.
this diagram. The other one's used for a different circuit.
Thank you. One, that other three-way switch is actually used for these two lights, and it's coming from a completely different circuit.
Same with way up on the top where it says UFCI, there's an SP or, I think,
Yeah, that says static light goes to one.
yeah.
This one goes to the attic.
Something else that
Yeah.
we don't have the circuit.
They're circuited, remember, we went through that one, they're circuited in a different circuit.
Okay.
So what you're talking, what they did, I believe, if I remember right, they get these, and they went in the house to turn it on and off from a different circuit.
Okay.
Absolutely right. They're not part of this circuit, but they're powered though. Any question, guys, about the circuit? Can I trust that you guys can look at the layout and go back into the point wiring? And I like, Chris, that what you're doing, putting them in visual. That was really cool. Then you can, it's a really good exercise to, if you're not good with wiring, guys, I can't emphasize. This is a really good, very simple layout to go point-to-point wiring. If you want me to walk you through them, I'll be more than happy to do so. When we do wiring, remember two things. Every receptacle need a hot and a neutral, and every light need a hot and a switched, a neutral and a switched hot. And every switch right now, every switch need a neutral and they need a hot to feed it and a hot to go out of it. Every switch, right? If you think of any switch, every switch need a hot and need a switched hot or switch leg and need a neutral, 3 wires. If you have a 3-way switch, you need also 2 travelers and a neutral and another hot or switched hot, 4. So if you know this one, guys, the way I always this need 2 wires. If you have the receptacle, this need 2 wires. If you have a switch, a 3-way switch need 4 wires. If you have a single pole, do we have a single pole switch right here? Single pole switch need 3 wires. If you know this, every receptacle need 2 wires. Every light need 2 wires, and every switch need 3 wires, and every 3-way switch need 4 wires. You would never go wrong again. How many switches a 4-way switch need? Landing on it, 2, right? Plus the neutral, 5. A 4-way switch need 4 wires to make it work. Why 4, guys? 2 from this side, 2 from the other side, and 1 neutral sitting in there. And the ground, all of them need a ground. Any question, guys? Any question? Chris, any comments? Did we miss anything? So I trust, my friend, that you guys will do that. If you don't have, let me finish that second chapter very quick here. And I don't know if chapter 17. No, I don't want this one. Chapter 17, guys, talk about recreational room. Let me review with you recreational room, guys. Is the recreational room habitable room? Yes. How many receptacles does it have? The rule of 6/12 and the rule of 2 feet or more need a receptacle. Does it need a light? Yes. You need at least 1 light, 1 outlet. All the receptacle have to be arc fault interrupters. All the light have to be arc fault interrupters. So that's basically what this recreational room is. They decided to go more than that, and they put a couple of outlets. So a couple of things I want to go directly. Let's go directly to the fixture. If you guys look at the way they did this recreational room, okay, I'm going to go directly into the fixture, the No. 17. Oh, here you go. If you guys look at the way they wire them, now, Rob, my friend, if I want to wire this room based on the code, how many circuits do I need? If you continue 10 or less receptacles in one circuit, that's all what you need. So let's count them, guys. If you count, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I have 23, 24. 24 things. So that will get you almost 3 circuits. Almost 3 circuits. 23, based on the rule that I gave you, 10, right? So that's what they brought. They brought actually 3 circuits. They brought one circuit here. If you guys can see this circuit is feeding all these recessed lay-in, they call them lay-in, exactly like above your head, recessed lay-in fluorescent lights, 2x4 lay-in fluorescent lights. You set them right in the grid because they have a grid there. And they bring it to a J-box and you loop it with a fixture web. You're going to look at that. So they brought the circuit here, guys, and you fit all these, and then they came up with a dimmer right here to dim all these lights, and I think there's another light that's going somewhere else, the other way. So that's one circuit to feed all the lights. So that circuit is feeding each and every one of these lights through a dimmer. The second circuit, they brought 2 circuits, guys. They brought 9 and 11, multi-wire branch circuit. And if I understand right, I think they brought one of these circuits to feed this receptacle, this receptacle, this receptacle, this receptacle, as well as all the lights. Okay? And the second circuit, one of them is feeding these receptacles on this wall plus these lights. So they have 3 circuits. They have 3 circuits coming to this area. One of them is a multi-wire branch circuit. So they brought the multi-wire branch circuit. They took a hot and a neutral, fed all this area. When they reached here, there is a switch. How many receptacles do I, how many, I need a hot and a neutral coming to it, and out of it, a hot and a neutral going to the light. How about this one need a hot and neutral to power it? And then the rest of them, that side here, guys, came and fed all these. There's a bar here. On the bar, the code says if you have a receptacle within 6 feet of a sink, any sink, you need a GFCI. So here's a receptacle. These receptacles are within 6 feet of the sink, so it has to be GFCI. How many receptacles do I need on a sink, on a bar? As many as you want. This is not a kitchen. The rule 2x4 does not apply. Not a kitchen. So it's a good idea, guys. So if I were you, I will apply the same rule for the kitchen. What's the rule for the kitchen? 2x4, 2 from every opening, 4 in between. Good idea. If you have a bar, you have a reason for having a bar, right? To entertain, you do a lot of other stuff. Any question, guys, about these? How they circuited? They use a multi-wire branch circuit. One second.
Is there any way of telling which goes to which from that diagram?
Which goes to which? Really, no. You have no. I can tell you one thing. I can tell you that this is only one circuit. Why can I tell that this is one circuit? Conductor. But right here, very good point. Chris is saying from right here, can I tell which this receptacle going to which circuit? Unless you read through the book, you really can't. You read, right? How can you? It could be circuit. What was the number of the circuits? It could be circuit 11 or circuit 8 is the second one. It could be any of these 2 circuits going to circuit 9 or circuit 11. So you can't in this case.
What's the significance of the A and B on the fluorescent lights?
A and B. A and B, are they switching them? A, B, B, A, so B, 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 B. I can't remember. It's not the fixture type. These are J boxes. These are J boxes. What they're wiring them, they're bringing the circuit to a J box, and out of the J box, they have a loop that feeds the fixture. That's typical from the J box. They're not going from J box from fixture to fixture. Can I go from fixture to fixture, guys? Yes, but I can't remember what the. Does it say anything on the book? I honestly can't remember.
I would think they would switch.
They only have one switch though.
Yeah, I know.
They only 2 light, unless they have another switch somewhere else. B, B, B. They're all B except one of them is an A. I can't remember.
Oh, maybe one comes on individual and the other one's off from together.
Yeah. I can't remember. But look how many conductors we have here. We have 4 conductors here. So I have a neutral, and I have 3 hots. I have to have a switched hot and a hot. And yeah, just looking at this, it will tell you that probably this one here is in one switch. Maybe that's why this is going that way. So this is in one switch, and the rest of them are on a different switch. How can you tell by looking at this one? I think there's my neutral. I need a hot, and I need another hot if they're all on the same switch. So you have 2 levels of switching. A is one switch, and B is in a different switch.
On the very bottom it says 2 light. What's the other end of that?
I can't remember. Let's look at where that goes to the light. We have to look at the whole picture, guys. It's going to. If you look at the sheet, it's part of a whole system. If you look at the sheet, and this is where we're in the recreational vehicle room, kitchen, in the basement, it says going up to R. It's actually showing it as different here as R. SB, there's a stairway that's going all the way up. And from down, yeah, it's going somewhere into the stairway. To down, yeah, there's a 3-way switch. To the 3-way switch. So SB and to S3, 3. I see 3-way switch, guys, in 9. I think there's a light, but they're not showing it though. Yeah, they're showing a light at the top, but they're showing what this arrow is going. SB, R. The diagram is different than, if you look at the designation, the diagram is different than what we show in the switch here. So anyway, so there gotta be something, guys, that's going in here to feed another light or something. Let's assume it's going feeding another light. So it could be anything for all practical reasons.
Okay, so just continue that.
It continues on that circuit. But I can't see where it's going though. There's a 3-way switch. You can see that 3-way switch here. This one goes to a light here and to another 3-way switch, and then so turn this light on and off. The other one I can't tell where it's going on from the diagram. Unless I'm missing something. Okay. So this is right at the top of it. Porch excavation. Okay. Any question, guys, about this other than where this is going? You can trace it. Any question? Any question about that? All these have to be arc fault circuit interrupters. If GFCI within 6 feet of a bar. And what they did here, guys, I think they have a sub panel in the corner here. Sub panel, panel B, that feeds in the corner. Chris, if you look at 8, the fixtures have RR, yeah, this BBB, yep, A.
Yeah, I'm looking at it. So it's a light when you turn the stereo lighting on, the bottom one comes on too. So
yeah, so B actually turns all the B's, and A, I see what they're doing. You know what they did?
Yeah.
They're taking this fixture and they're putting it on the 3-way switch. They're taking, guys, this fixture here and they're putting it on the 2 3-way switches. So as you turn it in, you turn this fixture and this fixture on. But they're coming from different circuits though. I don't know why they mix them this way. Oh, because we're not looking at a fixture. We're looking at a J box. That makes sense. You're bringing all these to a J box, and then from the J box you can pick and choose which circuit. So okay, so all these B's, guys, are controlled from the switch here, the B, and this fixture plus the fixture at the top are controlled from 3-way switches. I think that's exactly what they're doing. Good point. Any question, my friends? Any question? There's a really nice wiring diagram that I would like you guys to do for this. Okay, so this is, okay, so this is one. So Chris, here's the fixtures that they're using here. Type of fixture, lay them in and mount them with a clip to the suspended ceiling. This is how they wire them, guys. This is typically what we do in commercial, guys. There's a conduit or a cable coming in and a fixture web, no more than 6 feet. You don't have to support it. Fixture web coming from a box to feed the recessed lane fluorescent light. Then we got into the layout. What they're using, guys, is a multi-wire branch circuit, and they're telling you the advantage of a multi-wire branch circuit. We talked about multi-wire branch circuit, guys. What's the advantage of multi-wire branch circuit? Less wire, less voltage drop, less losses in the line. You're going to see it, less losses in the line, less voltage drop, less wire, less losses in the line. These are very important. What's the disadvantage of multi-wire branch circuit? You open one and neutral. No, you really open a neutral, you burn the equipment. Is this a multi-wire branch circuit? If I want to feed these two, is this a multi-wire branch circuit? Do I have shared neutral? What's a multi-wire branch circuit? Shared neutral. Then up to this point, as you can tell, is this a multi-wire branch circuit? No, it's not a multi-wire branch circuit. Now, is this a multi-wire branch circuit? Yes. Why do I save? So if you guys look at what they did, we saved, so less wire, and lower voltage drop, and also lower losses. These are the advantage of a multi-wire branch circuit. Now, less wire, you guys can see that this is a less wire as we, right? Less wire, you can tell that's a less wire. Less voltage drop, I will remind you guys, voltage drop equal to K-I-L over Cm. Now, what's the voltage that I'm using in a multi-wire branch circuit? What's the voltage that I'm using? The voltage that I'm using in multi-wire is the 240, right? Here's my 240. And only the losses is only in this cable and this cable. Can you guys, do you agree with me? Do I count the losses in this cable here? No, when they're balanced. So by counting the losses only in two cables, the neutral is not counted. It will save you also on the voltage drop. And there's an example how the voltage drop will be less on a multi-wire branch circuit. Less voltage drop. Everybody can see, guys, a 10 amp came here, a 10 amp came here. Right at this point, they neutralize themselves to big fat zero, right? Multi-wire branch circuit, they neutralize themselves to a big fat zero. What's the problem with multi-wire branch circuits? Multi-wire branch circuit, guys, you have to tie them together. Can you guys see how these circuit breakers are tied together? Now, let me just take you through this example. What happened if you... What happened, this is really nice example of what happened if you open a neutral. If you open the neutral, guys, first you need to find the resistor for each load. There's a resistor for each load, right? And then, then from the resistor, from the 240, look, can you guys see that these two are sharing 240 now, as if the neutral does not exist here? So that will get you 10. Right. So yeah, when this is 10 plus 12, then it becomes 10 and 12 in series. You take the current, 10.91. If you multiply the current by the resistor, look at this voltage. So one light is going to have 109 volt, and the other light is going to have 130. So, Nick, my friend, here's what's going to happen. Light number 1 will dim, and light number 2 will go brighter. If that was a motor, this what's going to happen. If that was a motor, this will have low voltage on the motor, and this will have high voltage in the motor. These voltages are not substantial, but if it was like 80 volts and your motor is running, your motor is going to start coming with smoke, because the motor guys keep pulling more current to compensate for the loss of voltage. Keep pulling more current to compensate for the loss of voltage. And by doing that, they burn your equipment. They burn your equipment. Any question? Any question, my friends? Everybody knows what they did here? They took the voltage divided by the current that's going at this point to find the impedance. The voltage divided by the current. So we found it, and then add the resistor together. We'll give you 240. When you add the two resistors here, 22. When you add these two together plus, then you take the total voltage divided by this to find the actual current after you lost the neutral. You came up with 10.91. Multiply it by each one of these resistors, and then you can see the after you disconnect the neutral distribution of voltage. It's going to be screwed up. Any question, guys, about this? Any question? Very, very important. What happened to your equipment when you have an open neutral? You just killed your equipment. You just killed your equipment. Okay, the last thing I want you guys, when you have a chance, is please wire this one point-to-point wiring. Point-to-point wiring. I know the most important things to remember, guys, when you do point-to-point wiring is every receptacle have to have hot and neutral. Every switch have to have a neutral as a hot and a switched leg. 3 conductors. Three-way switches, you have to have a traveler, a neutral, and a switched leg or a hot, 4 conductors. If you have a 4, like we talked about, a 4-way switch, you need to have 5 conductors to make the system work, coming to the 4-way switch. 5 conductors. 4 travelers in, out, 1 neutral, and that's it. Any question, guys, about wiring this? If I ask you, Chris, right now to wire this without the layout, and even reading, because this is multi-wire branch circuit, you need to know which circuit went, like these receptacles. When you ask me, where did this go? This go to circuit one of the circuit, B9 or B11, but it really could be any one of them, unless you read through the description that they designed it for. Any question, guys, about multi-wire branch circuit? That's it for this. Just to recoup, recreational areas are habitable areas. They need a receptacle every 6/12 rule. Every 2 feet wall need a receptacle. All the receptacle have to be arc fault circuit interrupters. All the receptacle have to be tamper proof. You need a light. The light could be a switched receptacle or could be a light. You have to have a switch receptacle or at least a light, some type of a light. How many circuits? We can get away with 1 circuit if we decided to put just 1 light in the middle of that room and call it a day. 1 circuit with all the receptacles. They have a sink, a bar sink. Bar sink, guys, the code says if you're within 6 feet of any sink, you have to have GFCI receptacle. How many circuits do you need for the bar sink? The code doesn't say anything about it. The rule that I told you guys, no more than 10 receptacle or lights in 1 circuit, that's probably if you apply, you end up with 3 circuits. Is it overkill? Yeah, they're making it entertainment room. They're not making it just any recreation room for kids or whatever. You know, there's a bar there, there's entertainment. Any question? Questions? Is the chapter hard, guys? No? Less? More? So that's, I want to see if we forgot something. Talk about the fluorescent lane, 3-wire way switch, neutral. If you read through it, guys, it did some calculation for the voltage drop that I thought it was really interesting. They did about here's the impedance that they found. Chris, my friend, they found the impedance and they find the losses. Here's the losses for 1 conductor. If you multiply the 2 conductors, that will get you, here's the voltage drop for 1 conductor. If you multiply this by 2, that will get you the voltage drop for 2 conductors. And then they did it for, why do you think they multiply this by 2? Because there's voltage drop in 1 conductor and the other conductor. So that's it, came up with 2. So if they subtract this from the 120, look at the operating voltage if you're running non-multi-wire branch circuit, 116. If you run a multi-wire branch circuit like this, look what happened. The voltage drop is 15 I squared R, and if you multiply it by 2, it's going to be 30. The first one, Chris, this is 30 because 2y2 because there are two wires. The first one, if it's not multi-wire branch circuit, you have to multiply this by 2 again. That'll give you 30. So you cut the losses in the power, guys, the losses in the cover by half. Because remember, the first circuit has 2 wire, the second circuit has 2 wire, 2 wire, 2 wire. So this is only for 1 wire. So for 2 wires will be this. For 4 wires, because we have 2 circuits, will give me 30, right? It will give me 60. I'm sorry, 60. That will get you a 60, right? Because there are 2 circuits, it'll give you a 60. 60. Now, if it's a 2-wire circuit, multi-wire, then what happened to the neutral? The neutral doesn't count. All these circuits are tied together. So the only 2 wires are only 2 wires. That will multiply by 2. You get you half. You cut the losses by half, the copper losses. Now it doesn't matter, guys. That's not a whole lot if it's one multi-wire branch circuit. Imagine the whole building is multi-wire branch circuit. That makes a big difference. Look at the voltage drop. The voltage drop, guys, in each circuit, the same thing. You got 3.3, but the 3.3, Chris, coming out of the 240, not the 120. That's a major difference. That voltage drop still the same, but it came out of 240 because they're as if they were connected to 240. We'll give you this amount, cut it by half because it's going to be shared. That will get you 118. Before it was 116. 116 volt. So if you use a multi-wire branch circuit, you gain 2 volts in the voltage drop. Is that good, bad, or ugly? Good. Another advantage of multi-wire branch circuit. Less copper, less voltage drop, less losses in the line. Less losses in the line. Okay, so that's basically what I have for you. Again, multi-wire branch circuit, less wire, smaller raceways, smaller raceways, less voltage drop, less power in the line. Any question, guys? Take this one, tell my friend, if you're using multi-wire branch circuit here, and here's your light, bam, 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 and you're using a neutral shared, bam, 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 and this is a 480 system, 480 volt. Look at the voltage drop in the whole system here. If you're doing lights and you're doing a voltage drop on 20 amps, I'm going to do it very fast. Voltage drop equals 1.73 times RIL, R-I-L over 1,000. This becomes a 3-phase, right? Because this is light, but they're shared neutral. They will be seen as a 3-phase, and you apply the 3-phase formula for it. If you do the math on it, guys, you will need multi-wire branch circuit. You will see that the voltage drop will be much lower. Then, what's the alternative? The alternative is take this, and this. So here's 1, here's 2, here's 3, and do the calculation for each one of them. If you do the voltage drop for each one of the circuits, you're going to find, versus doing them all together, because they're multi-wire branch circuit, you're going to find this one will give you a substantial amount of less voltage drop than if you do a single voltage drop, hot neutral with all. What's the problem with them with the electronic ballast, guys? Because of harmonic, now you can overload your neutral. So if you load your circuit to 70% in commercial building to what's rated, most likely you're not going to be overloading your neutral. 70%, not 80%. Another option with commercial, when we go commercial, Chris, is they use. Okay. All right. Let's go. That one accused me.
That was your chance.
That was my only chance.
Rob just said that I take a depth first.
That was long, wasn't it?